Hello students, today we will discuss about the solution of exercise 7.3. This exercise mainly on area of triangles from 3 vertices if the coordinate of 3 vertices are given. So let us start with question number 1. Question number 1 is find the area of the triangle whose vertices are, first one is 2, 3, minus 1, 0, 2, minus 4. As you can see here, if x1, y1, x2, y2, x3, y3 are the vertices of a ABC triangle, then the area of the triangle will be half of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. I have discussed about this formula in the previous video. Now, in place of this x1, y1, x2, y2 and x3, y3, 2, 3, minus 1, 0, 2, minus 4 are given respectively. Okay, so you can consider this A point as x1, y1, okay, B point as x2, y2 and C point as x3, y3, and put the value of x1, y1, x2, y2, x3, y3 in this formula. So the area of the triangle will be this one, that is if we do the simplification, it will be 21 by 2 or 10.5 square unit. Similarly, if we look for the second part, in the second part the vertices are given as minus 5, minus 1, 3, minus 5, 5, 2. So similarly, we will consider this point as x1, y1, okay, sorry. Similarly, you will consider this point as x1, y1, this point as x2, y2 and this point as x3, y3, and the formula is same. Just put the value of x1, y1, x2, y2, x3, y3 in the formula. You will get the area of the triangle as 32 square unit. Okay, now next question. Question is, in each of the following find the value of k for which the points are collinear. Okay, I have discussed about this situation. If 3 points are collinear, that means these 3 points lie on the single line. Okay, that means these 3 points are not making a triangle. Since it is not making a triangle, the area of triangle will be equal to 0. Okay, so I am considering this point as x1, y1, okay, this one as x2, y2, okay, and the third point as x3, y3. Okay, that means after comparing, you can say that x1 will be 7, y1 will be minus 2, x2 will be 5. Okay, and let me write x1 is equal to 7, y1 is equal to minus 2, x2 is equal to 5, y2 is equal to 1, x3 is equal to 3, y3 is equal to k. And what I said, since they are collinear, they will lie on the single line, and the area of the triangle formed by these 3 points will be equal to 0 because they are not forming any triangle. That means the area of the triangle is equal to 0. You know what is the formula of triangle. Just in place of x1, y1, x2, y2, x3, y3, put these values. You will get a equation. This is equal to 0. That means k is equal to 4. Okay. Similarly, if you consider part 2 in the similar manner, you will put the value of x1, y1, x2, y2, x3, y3 in the equation. That means area of PQR will be equal to 0. In place of area of PQR, put this formula. Okay, so you will get the value of k is equal to 3. Okay, now the next question. Question number 3. Question is, find the area of the triangle formed by joining the midpoint of the sides of the triangle whose vertices are 0, minus 1, 2, 1, 0, 3. Find the ratio of the area to the area of given triangle. Okay, Suppose the coordinate of PQR triangle are given. Okay, so suppose the P is the midpoint of AB. This P is the ABC triangle is given. The vertices of A is 0 minus 1, B is 2 1, C is 0 3. Now P is the midpoint of AB, Q is the midpoint of AC, and R is the midpoint of BC. Now you have to find the area formed by the midpoint of the sides of the triangle. That means you have to find the area of this triangle. Since P is the midpoint of AB, you can find the coordinate of P by section formula. What was the formula? It will be 0 plus 2 by 2 comma minus 1 plus 1 by 2. Okay, that's why it will become 1 comma 0. So as you can see, the coordinate of P is 1 comma 0. Similarly for Q point, it will become 0 plus 0 by 2 comma minus 1 plus 3 by 2. That's why 0 comma 1. Okay, so Q is 0 comma 1. And for the R point, it will be 2 plus 0 by 2 comma 1 plus 3 by 2. That's why it will become 1 comma 2. Okay, so now you are getting the vertices of PQR. So you can find what is the area of the triangle PQR from the area of triangle formula of 3 vertices. Okay, so first of all, you are evaluating the coordinate of PQR. Then area of PQR formed by the midpoint of the side of ABC. If you put the value of the coordinate of PQR in the formula, you will get the area of PQR as 1 square unit. Okay, also the coordinate of ABC is given, so put the value of coordinate of ABC in the main formula of area of triangle. You will get the area of triangle ABC is equal to 4 square unit. So the ratio will be area of triangle PQR is to area of triangle ABC is equal to 1 square unit by 4 square unit, that is 1 by 4. So the ratio of area of PQR, you can write area of PQR is to area of ABC is equal to 1:4. Okay, in this way you have to solve this question. Now question number 4. Find the area of the quadrilateral whose vertices are taken in the order are minus 4, minus 2, minus 3, minus 5, 3, minus 2 and 2, 3. So I am considering this point as A, B, C, D. This one is A, this one is B, this one is C, this one is D. Okay. Now if you join the diagonal AC and BD, okay, if you join the diagonal AC and BD, as you can see, AC diagonal will bisect this whole quadrilateral in two equal sections. One is ABC triangle, another one is ADC triangle. So for ABC triangle, means for this triangle, the coordinate of A, B, C are known. Just put the coordinates in the main formula of area of triangle. You will get the area of triangle ABC as 10.5 square unit. Okay. Now similarly, if you consider ACD triangle, that means this lower one. Okay. Then again use the formula of area of triangle since 3 coordinates are known. So it will be 17.5 square unit. Okay, that means this part is 17.5, this part is 10.5. So the area of the whole quadrilateral will be 17.5 plus 10.5. That means the area of the quadrilateral ABCD is equal to 28 square unit. Okay, now the next question. Question number 5 is, you have studied in class 9 that a median of a triangle divide it into two triangles of equal area. Verify the result for triangle ABC whose vertices are given as 4 minus 6, 3 minus 2 5, 2. Okay, so suppose this is the triangle whose whose vertices are given 4 minus 6, 3 minus 2, 5, 2. Okay, now AD is the median. Okay, this AD is the median. You know that a median will divide the opposite side in two equal parts. That means D is the midpoint. Okay, this D point is the midpoint. Okay. Now, since this one is the midpoint, D is the midpoint of BC, and the endpoint B and C, the coordinate of the endpoint B and C are given. So the coordinate of D will be, by using midpoint section formula, 3 plus 5 by 2, comma, minus 2 plus 2 by 2. That means it will be 8 by 2, that is 4, and it will be 0. That's why the coordinate of D is 4, 0. Okay. Now, as you can see, this AD will divide this triangle ABC in two parts. One is ABD, another one is ACD. Now, for the triangle ABD, the coordinate of ABD is given. So, you can use the area of triangle from 3 vertices formula. Okay, and you can find that the area of the triangle ABD will be 3 square unit. As you can see here, the value first of all becoming minus 3, but since the area cannot be negative, that's why I am considering the numerical value. That is, I will not consider the sign, negative sign. I will consider only the numerical value, that is 3. Okay, so that's why area of ABD is 3 square unit. Again, if you look at ACD triangle, again the coordinate of ACD are known, right? That's why again put it in the formula of area of triangle. You will get the area of the triangle ACD is 3 square unit. Now, as you can see, the area of ABD and area of ACD is equal to 3 square unit. So you can conclude that a median of a triangle divide the triangle in two equal triangles, or a median of a triangle divide it into two triangles of equal area. Okay, so you have clarified that theorem. So this was all the questions for exercise 7.3. Okay, so this is all for today.